You know the feeling, right? Your app is just sluggish. Reports are taking forever to load, and weird bugs keep popping up out of nowhere. And our first instinct is always to blame the code, maybe the servers. But what if the real problem is something deeper, something hidden in the very foundation of the whole system? One developer on Reddit just hit the nail on the head. They said most of the issues people complained about weren't bugs, performance, or missing endpoints. They were caused by weak data models. And that insight right there is a total game changer. It makes you stop fixing the symptoms and start looking for the root cause. So let's pull back the curtain on this problem that's so often hiding in plain sight. I bet these frustrations sound pretty familiar. You've got reports that take ages to load, turning big business decisions into a frustrating waiting game. The whole application just feels slow, clunky. And for all you developers out there, you know that heart-stopping moment when a tiny little code change somehow breaks a feature on the complete other side of the app. When you see teams start copying and pasting data into spreadsheets just to get their work done, well, you know something is fundamentally wrong. This isn't just an inconvenience. It's like putting the brakes on the company's growth. But here's the thing to remember. These are all just symptoms. They're the cracks you can see on the surface. So what's the real problem buried underneath it all? Well, the answer lies in the foundation of everything, the database. Another developer put it perfectly. The data model is the most important part. Everything else depends on that being correct and finalized. It's the foundation of the whole project. It's so true. If that foundation is cracked, everything you try to build on top of it is just gonna be unstable. Now, to really get why this foundation is so critical, let's make sure we're on the same page about two key ideas. First, you have data. These are just raw facts, like a single sales order. On its own, it doesn't really tell you much. But then you have information, and that's data with context. It's what happens when you take all those individual sales orders and suddenly you can see your monthly sales trends. A good database is all about turning that raw data into useful information and doing it efficiently. And this really shows you the difference between chaos and order. So many teams fall into this trap of using spreadsheets as if they were databases. The big problem? You get massive data redundancy. You know, the same customer info stored in 10 different spreadsheets. And that leads to major integrity issues. If you change it in one place, but forget the others, boom, your data's corrupted. A properly structured database, on the other hand, is your single source of truth. Data is stored once, period. And strict rules make sure it stays consistent. This isn't just about being neat. It's about being reliable. Okay, so we've figured out the problem. Now, how do we actually fix it? It all starts with designing a proper digital blueprint for our data. The very first goal of a good design is super simple: reduce data redundancy. It's a key part of a process called normalization, and it just means every unique piece of data should live in only one place. A student's name belongs in the student table, and that's it, nowhere else. The second goal is all about ensuring data integrity. Basically, this means making sure your data is always consistent and reliable. And we do this by creating really clear, defined relationships between our data. So if a grade gets entered, the system has to know exactly which valid student and which valid course it belongs to. No guesswork, no ambiguity. So here's a really simple blueprint of how this works. Let's imagine a university database. You've got a student table with all the student info, and the student ID is the unique identifier. We call that the primary key. Then there's a course table, where course ID is its key. So how do we link them? With a grade table. Now this table is smart. It doesn't repeat the student's name or the course title. Instead, it just uses foreign keys, the student ID and course ID, to point back to the other tables. This creates this clean, efficient, and unbreakable link, making it impossible to assign a grade to a student or a course that doesn't even exist. And the payoff for getting this right is just huge. Remember that first Reddit user we talked about? They followed up by saying, once the schema plus constraints were done properly, the API became almost boring in a good way. And boring is exactly what you want. It means it's predictable, it's reliable, it's simple to work with, all because the database is doing the heavy lifting of enforcing all the rules for you. But a solid foundation isn't just about being organized and tidy. It's about unlocking some incredible speed and the ability to scale up. See, when your data model is solid, you can start adding powerful optimizations. And these aren't just patches you slap on to fix a slow system. They're enhancements that make a fast system even faster. Things like caching and indexing become these incredible tools for optimization, not just emergency fixes for a broken design. Let's take caching, for example. A really common pattern is called cache aside. When your application needs some data, it first checks a super fast in-memory cache. If the data is there, we call that a cache hit. It comes back instantly. If it's not there, a cache miss, no problem. It just queries the main database, stores that result in the cache for the next time, and then returns it. This makes a massive difference for accessing data you use all the time. Now, the performance boost from indexing can be absolutely staggering. Think of an index like the index in the back of a textbook. Without one, your database has to read every single row, a sequential scan, to find what it's looking for. It's so slow. But just look at this chart. With the right kind of index, in this case a GIN index that's built for text searches, the search time just plummets. We're talking a drop of over 98%. That's not just a small improvement, that's a total transformation. And indexing can get even more specialized. For huge amounts of time-ordered data, like system logs or sensor readings, an index called a BRIN index is unbelievably efficient. As you can see here, it keeps query times lightning fast, even as the data grows into the hundreds of millions of rows. How? Well, it works by summarizing big chunks of data at once, sort of like knowing which chapter a word is in instead of the exact page, which makes it both super fast and compact.
So what this all boils down to is choosing the right tool for the job. You wouldn't use a hammer on a screw, right? You need the right kind of index for the right kind of task. The key takeaway here isn't to memorize all these names, but just to understand that whether you're dealing with standard transactions, text searches, or massive analytical data, there's a specialized tool that can give you a dramatic performance boost. A really well-designed system will use a mix of these to optimize every single part of the application.
Okay, let's tie this all together. Why should business leaders, not just the engineers, care about this stuff? Because a well-structured database directly hits the bottom line. It means faster dashboards and reports, which leads to better decision-making. It means a snappier customer experience, which builds loyalty. It means lower cloud and infrastructure costs because you're running way more efficiently. And it means fewer late-night engineering emergencies, freeing up your team to build new, money-making features instead of just fighting fires all the time.
This really just sums it all up perfectly. Databases aren't exciting, but bad ones are expensive. That investment in good design right at the start pays for itself over and over again by preventing the massive cost of bad performance, frustrated developers, and stunted growth.
So, as we wrap this up, I'll leave you with one final question to think about for your own projects, for your own companies. Is your data structured for growth, or is it secretly holding you back?